I'm Keming. I'm a research engineer from the Qwen team, and I mainly work on the alignment of Qwen. I'd like to first appreciate the invitations from our organizers to provide us an opportunity to share Qwen and how we build such an open source model. So actually, we are a very active open source team. We have released high-performance large language models in 4 sizes from July this year. So you might know us from the open source community or some popular leaderboards. Or you may just read a week too strong generation report released by OpenAI yesterday and notice there are a group of models called Qwen. Well, so what is Qwen? As there are plenty of open source large language models out there, I'd like to first share what makes Qwen unique and also show our original motivation for developing such a series of open source models. As for the motivation, we bring up the chinchilla scaling law here. Just like most of the concurrent works, we also believe LLMs at that time may be undertrained, and we would like to build a series of open source models to further explore what may happen if we scale up a model and data size. So from August this year, we gradually released Qwen with 7, 14, and now 1.8 and even 72 billion parameters to the open source communities. The 2 smaller models are trained on about 2.4 trillion tokens, and 14 and 70 billion models are trained on over 3 trillion tokens. They are all equipped with 2 using and system-prone abilities and support long contact up to 32,000 tokens. The progress are mainly come from the pre-training data. As our objective is to model human knowledge, we have to collect as diverse data sources covering different domains as much as possible. We also upsample valuable resources such as a lot of books and Wikipedia for high-quality pre-training. Well, we would like to train Generalist. It can't be restricted by language, so it has to be a multilingual model. We carefully clean this corpus by rules and some pre-training models for deduplications and quality control. And we also experiment various data mixture recipes. So I would say there is no magic in this process, but only efforts. And to leverage rich multilingual corpus, especially Chinese corpus, we choose to extend the tick tokenizer as we found it efficient on tokenizing for codes. We further extended to 150,000 with multilingual unique tokens. And this large vocabulary significantly improved the efficiency on decoding multilingual data, which means you can use the same amount of token to express more information. And further, it can further improve multilingual performance in comparison with the Llama tokenizer as shown in this picture. For more general performance, the largest model, Qwen 72 billion, surpassed Llama 2 on a series of multilingual benchmarks. If you are specifically focused on Chinese abilities, Qwen 72 billion can be on par GPT-4 and most of Chinese benchmarks like CEVO, very popular knowledge benchmark in Chinese, which also presented in NeurIPS yesterday, and CMMLU and Gaokao benchmark to measure the reasoning method of the models. And we also dive deep into the demand of long context. Our models are pre-trained on 8,192 tokens, and then we use techniques like dynamic NTK or attention scaling to further extend it to 32,000 tokens. There is a very interesting findings that we find if we continually pre-train an off-the-shelf model with a longer context, with a larger base of rope, it can still successfully reduce perplexity in long contexts. Our 72 billion model with 32,000 input lengths can be on par GPT across the LEL benchmark, which contain a bunch of tasks requiring long context understanding, and even significantly outperforming on some subtasks, like TOEFL. We also test Qwen on the recently popular test, needle haystack task, which requires Qwen to retrieve facts from given documents across different lengths and document depths. Qwen can successfully retrieve the target in most of the document within 32,000 tokens. And as you can see, they are all green, which means close to 100% retrieval on the task. And that's for the base model. We also built a chat model as an AI assistant based on Qwen. We call it Qwen Chat Series. So I will also share some interesting progress on our alignment. Our alignment starts with supervised fine training. As for the SFT, we realized high quality data is the key. We have analyzed almost all open source datasets, and we noticed diverse and complex SFT data may lead to versatile and strong instruction following abilities, which we have shared in a recent paper named Instack. We also test this assumption on Qwen, and when we scale up the diversity, complexity, and quantity of fine training samples, model performance are dramatically improved. Well, however, it is very challenging for us to improve the size, quality, and diversity of data at the same time. So to combat this issue, we actually hire lots of human annotators for data quality control and involve very diverse instruction from our user logs. We also pre-train and fine-tune our own reward models and apply PPO for further alignment with RLHF. But we noticed RLHF aligned models are significantly more informative and creative. It shows stronger instruction following abilities, but also showing worse hallucinations. So that's mainly the reason why we just only open source the SFT model now. But we definitely plan to open source an RLHF of a PPO chat model in the near future. And here's the human evaluation result measured by the win rate versus GPT 3.5 across 5 different domains. And we noticed LLM can improve almost all aspects in this evaluation. And for multimodality, we also open source large language models, large models in multimodalities, like Qwen VL is a large vision language models, and Qwen Audio is an audio specialist. Both models are built on top of our large language model Qwen. And Qwen VL actually is the multilingual version of our large language model series. It is the first generalist model supporting grounding in Chinese. And it supports more fine-grained recognition and understanding with 448 resolution. And Qwen Audio can accept diverse audio on the right side, like human speech, natural sound, music, and song, along with text as inputs and output text. It adopts a multitask learning framework for all types of audios, which help they achieve impressive performance across diverse benchmark tasks without requiring any task-specific fine-tuning. And come back to open source. One of our goals is to help open source communities. So we provide solid guidance of inference, fine-tuning, and development of Qwen to make sure every developers and researchers in the open source community can easily use Qwen as part of their works. To be more specific, we collaborate with AutoGPT-Q to provide various versions of our model series. As you can see on the table in the right side, every size of our models can be quantized to 3 different small models for efficiency, so that developers and researchers with limited computation resources can also run our models. And we also collaborate with multiple open source infra, such as VLM just mentioned in the last talk, and FastChat to provide smooth development and fine-tuning recipe. So you can deploy or train Qwen in any size efficiently with the support of these 2. And here are links where you can learn more about Qwen. You can access and download our models on Hugging Face or Monoscope, and even play it with from our online demo. You can find a very detailed instruction containing all you need to deploy or fine-tuning Qwen in our GitHub repo. And you can also learn far more details beyond this 15-minute pitch from our technical reports. So that will be all for this talk. Thank you so much for listening, and please consider to join our Discord channel if you are interested in our models or just have any questions you would like to ask. Thank you.